Question number 39. Positive charge capital Q is distributed uniformly over a circular ring of radius r. A particle having a mass m and a negative charge small q is placed on its axis at a distance x from the center. Find the force on the particle. Assuming x is less than r, find the time period of oscillation of the particle if it is released from there. So small q having negative charge is placed at point P. So let's find out the electric field at this point first, and then we will apply F equal to QE, and finally we will find out time period. So we consider this charged ring where charge Q is distributed over its circumference. So we can say charge per unit length lambda equal to Q divided by 2 pi r. Now we consider small length element dl here and another point dl here diametrically opposite, and we will consider the electric field contribution due to both of them. So due to this current element dl, electric field will be like this. Its component, if this angle is theta, this angle is theta, so its component d cos theta will be along this direction and d sin theta will be in this direction. Similarly, if we consider diametrically opposite point dl, so this is current element. So due to this current element, electric field will be like this, and this angle is again theta. So here d cos theta will contribute further, and d sin theta will be in this direction. So it is clear that diametrically opposite points of current element will cancel, and only cos theta component will contribute to the net electric field. So we can say that E will be equal to integration dE cos theta. Now let's see what is dE. So let charge contained in length dl is dq, and this dq will be equal to charge per unit length, that is q divided by 2 pi r, since charge q is distributed over the circumference 2 pi r, times length of current element dl. So it is dl. Now electric field E will be equal to integration dE. So charge, that is q upon 2 pi r dl times 1 upon 4 pi epsilon naught and distance square. If this distance is r, this distance is x, then s will be square root of r square plus x square. So r square plus x square times cos theta. So cos theta will be equal to base upon hypotenuse, that is x divided by r square plus x square whole power half. So here only variable is dl. Other things we can take out. So it will become qx divided by 4 pi epsilon naught times 2 pi r times r square plus x square whole power 3 by 2, and integration dl limits from 0 to 2 pi r will give L limits 0 to 2 pi r, which will be equal to 2 pi r. So we will get 2 pi r. So 2 pi r will cancel out, and we have got E equals qx divided by 4 pi epsilon naught r square plus x square whole power 3 by 2. Now we have to find out the force on charge placed at point P. Since it is negative q charge, so there will be force of attraction, and its direction will be in this direction. So it will be directed like this. So we can say F equal to QE So that will be equal to capital Q, small q, x divided by 4 pi epsilon naught r square plus x square whole power 3 by 2. Now we make approximation. X is less than r, then x square can be neglected. So we will get qx divided by 4 pi epsilon naught. From here we will get r cube because x square will be neglected and then 2 will cancel out. So r cube. So this is force. Now we know that F equal to ma. So A will be equal to F upon m, that is qx divided by m times 4 pi epsilon naught r cube. We know that in case of oscillation, acceleration A is equal to omega square x in magnitude, although there is negative sign here also displacement will be like this, so it will be negative. So A equal to omega square x. So we can compare, this is A equal to qx divided by m times 4 pi epsilon r cube. So on comparing, we will get omega square equal to qq divided by m times 4 pi epsilon naught r cube. Now, our purpose is to get time period. So for that, since we know that omega equal to 2 pi upon t. So 2 pi upon t equal to this much squared equal to qq divided by m times 4 pi epsilon naught r cube, from where we get t equal to, or t upon 2 pi, we invert it and take square root, equals m times 4 pi epsilon naught r cube divided by q cube with square root. Now we write it further as t equal to 2 pi root of m times 4 pi epsilon naught r cube divided by capital Q small q. We take this 2 pi inside, so that will become 4 pi square times m times 4 pi epsilon naught r cube divided by capital Q small q under root. Clearly, this will become t equal to 16 pi cube epsilon naught m times r cube divided by capital Q small q under root. So this will be expression for time period. Thank you for watching.